So electrolysis in chemical cells, exercise one. This exercise was having multiple choice questions from the topic, and the doubts question six, two, 6, 7, and 16. So first is question two. The diagram shows a simple cell. So you can see this is a simple cell. A cell converts the chemical energy to electrical energy. And how this cell will work? In a cell, we always have two electrodes which are made from two metals which are having a difference in the reactivity. So one is zinc here, another one is a copper, and we know zinc is more reactive than copper. So what will happen in this zinc atoms are there, they will go inside the solution as a zinc ion. So zinc atom turn into zinc ion. So size of zinc, because zinc is more reactive, so it will have a greater tendency to lose electron. So as a result, the zinc atom will turn into zinc ion by loss of two electrons. And these electrons will travel from zinc electrode towards the copper electrode. And the electrolyte, usually we use acid as an electrolyte, and acid contain H plus ion. So this H plus ion is attracted towards the electron. So H plus ions will gain two electron and form hydrogen gas, so we'll observe bubbles. So the question is, which statement about the process occurring when the cell is in operation is correct? So copper ions are formed in the solution. Copper ions are not formed in the solution. Why? Because copper ions can only form if copper was losing the electron. But copper is not losing electron. Zinc is losing electron. That's why the copper ions are not formed. Electron travel through solution. Electron never cannot go through the solution. Electrons can only move through the wire or towards the electrode, respective electrode, but through the wire, cannot move through the electrolyte. Then the reaction zinc atom changes to zinc ion. That's true. Because zinc is more reactive, it will have a greater tendency to lose electrons. So zinc atom turn into zinc ion. The zinc electrode increase in mass. That is wrong, because when zinc atom turn into zinc ion, what will happen to the mass of this electrode? The mass of this electrode will start to decrease. So it won't increase, it will decrease. That's why C is the right answer for this. The next is question number 6. The doubts for this exercise. The diagram shows a simple cell. The electron always move from, remember, the electron move from more reactive metal to less reactive metal surface. So metal X should be more reactive and metal Y should be less reactive, because the electrons are moving from metal X to metal Y. So when we write the reactivity series, X should be, according to this direction of the flow of electron, X should be more reactive and Y should be less reactive. So we have the reactivity series: potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So if we check the combination copper and iron, if this was X was copper and Y is iron, because according to that, iron is more reactive, so the electron will move from iron to copper. So it should move from Y to X, not X to Y. We want to find a combination in which X is more reactive and Y is less reactive. So it is not feasible. Then if X is copper and zinc, so if X is copper and Y is zinc, so again the electron move from zinc to copper, it will move from Y to X. So again, B cannot be an answer. If iron and zinc, if iron is X and zinc is Y, so again the electron move from more reactive, so it will move from Y to X. It won't move from X to Y. But when we check zinc and iron, like if X was zinc, or X is more reactive and Y is less reactive. So then the electron will move from zinc to iron. That's why option D is the right answer. So always in a chemical cell, the electron movement is from more reactive to the less reactive. Then the doubt from this one, question 7 and then 16. In question 7, which statement about electrolysis is correct? So to understand the statement, I will draw electrolytic cell first. So we have two electrodes which are connected with a supply. One is a positive terminal of the battery, another one is a negative terminal of the battery. The one which is connected with a positive terminal is called anode, and the other one connected with a negative terminal is cathode. Inside the electrolyte, we have ions. So what will happen from negative terminal, the electron will move towards the cathode. And when electrons will move towards the cathode, these electrons will attract the positive ion. And the positive terminal of the battery remove the electron, so electrons will move out. As a result, most of the positive charges here, so negative ions are attracted towards the anode. Now we check the statements according to the, like we will check which is a valid statement. Electron move through the electrolyte. Electron never moves. Like this statement is totally wrong. Electron cannot move through the electrolyte, or electron cannot move through the solution. That's totally wrong. When we check statement, the second statement, that electron move towards the cathode in external circuit. So you can see clearly that these electrons are moving towards the cathode in the external circuit, the outside circuit. So that is a correct. So that's why B is the right answer. Why not C? The correct answer for this one is B. Why not C? The negative ion move towards anode in external circuit. The negative ions are not moving in the external circuit. They're only attracted towards anode. Negative ion cannot move in the external circuit. They can only move through the electrolyte, not in the wire. External circuit here include a wire, and the positive ion move towards the anode. The positive ions are not moving towards the anode. The positive ions are always moving towards cathode. So this statement is also wrong. So negative ions move towards anode in external circuit. In external circuit, negative ions are not moving. They're only attracted towards anode. And the positive ions are attracted towards cathode. But here it's written the positive ions move towards anode. That is totally wrong. They're attracted towards the cathode. Why the electrons are moving from negative? Because the negative terminal of a battery supply the electron. So it's always the case whenever you have a cell or a battery, it will always supply the electron because majority of the electrons are here. So these electrons start to flow and they will stop at cathode. This is what happened. And the positive terminal of the battery attract the electron from anode because unlike charges attract each other. So these electrons are removed. As a result, there will be a positive charge on the anode. So this is always the case that electrons move from negative terminal because negative terminal having majority of electrons. So as they repel, they move towards the cathode. And the positive terminal attract the electron from anode. That's why the electrons are attracted towards that. Then the last question, that is 16. In question 16, electrolysis of the copper sulfate can be done. Using carbon electrode or copper electrode, which statement describe what happened to the positive electrode? So there are two ways to do electrolysis. For copper sulfate, one we can use carbon electrodes. Another one we can use copper electrodes. So if you are doing electrolysis using the carbon electrode of aqueous copper sulfate, so the movement of electron, because from electrons always move from negative terminal towards the cathode. So majority of electrons will be here. And the positive terminal will attract the electrons, so electrons will move out. As a result, positive charges will be here. Now, when we are doing electrolysis, this is aqueous copper sulfate, so copper ion, sulfate ion, hydrogen ion, and hydroxide ion. Always less reactive positive ion will move, so in this case, the copper will move. So as a result, at cathode, the copper ions attracted towards the cathode, they will take two electron and it will turn into copper atom. So it will stick to the cathode. Then for negative ions, sulfate, nitrate, and carbonates never move, so it will always be a hydroxide ion. So when hydroxide ions are moving there, so when four hydroxide ions are moving there, they will lose four electron. It will go O2 plus 2H2O. Means oxygen will be there. There will be oxygen and water molecules. So there will be bubbles when we use a carbon electrode. But what will be the case if we are using a copper electrode? Like anode is made up of copper, cathode is also made up of copper, and the electrolyte is aqueous copper sulfate. Same thing happen in this case. The electrons move from negative terminal towards the cathode, and electrons are attracted from the anode towards the positive terminal. The copper ions are attracted because they are less reactive. So as a result, at cathode, the copper ions take two electron and it will form a copper metal. So it will stick to the cathode. As the amount of the copper ion is decreasing, to balance that, the copper atom from the anode will move inside the solution as a copper ion. So copper atom turn into copper ions by loss of two electron. This is what happened at anode and this is what happened at cathode. So if we use carbon electrodes or we use copper electrode, the cathode is same. Cathode equation is same. But anode, it changes. If we use a carbon electrode, it will give oxygen gas. If we use copper electrode, then the copper atom will turn into copper ion at anode. So we have to identify which statement describe what happened at a positive electrode, like anode. Copper is deposited if copper is even A and B are totally wrong. Why A and B are totally wrong? Because copper cannot be deposited at the positive electrode. Because we want to find what happened at a positive electrode. So as a positive electrode or anode, copper can never move because copper is a positive ion. Positive ions always move towards cathode. So copper cannot be deposited. Then what will happen if the electrode is made up of a carbon? Then oxygen gas is produced if the electrode is made from carbon. And if the electrode is made from copper, then as a result, there will be no oxygen gas. It will turn copper atom turn into copper ion, or the size of the anode will decrease. So if electrode or anode made from copper, the size of the anode will decrease here. But here what happened, the oxygen gas will be there, so we'll observe bubble. So that's why option C is the right answer.